Okay, this is math 2. We're going to do 108 to 115, and I'm going to breeze through a lot of these because we did literally 108 through 110 in class for most of you. 108, we did do most of these in class. So x ended up being 270 degrees because it came from being able to actually construct radii that were perpendicular to the tangent lines, and since this was 90, that was 90. This ended up being 90 degrees also. So this was 270 out here from 360. 90 plus 270 adds up to 360. On part B, we actually constructed a right triangle since this is a radii and those are tangent lines. Then this was a right triangle. This was 24 degrees because it was half of 48. And this ended up 66 degrees because 66, 90, and 24 make 180 in this triangle. So double 66 to get x, and then you needed to use tangent in trig to actually find the value of y. There's a triangle that looked like this. You had this as 7, this is y, this is 24 degrees, and then you can set up a tangent ratio to figure that out. And then part C, if you actually flip back one page, the proportional ratio of this comes out to 6 times x is equal to 3 times x plus 2. The chord, so this part of the chord times x plus 2, the rest of the chord x times 6. These two are equal to each other. They're proportional because you can actually create, am I doing this right? 3 and 6, x and x plus 2. 3 times x plus 3, 3, or... yeah, I think it's that way. Actually, it really doesn't matter. They're both going to end up being proportional anyways. And then solve for x. All right, and then 109, it was sketch a graph of the circle with the center at 4, 2. So we said, okay, we're going to have 4 and 2. So here's our center. We're going to have a circle with a radius of 3 going in all 4 directions. And since they're going in all 4 directions, it's going to be here, here, there, and there. And then your actual equation is going to end up being, what is it, x plus 2. I should do this with a pencil because we did this in class, so we should go pretty fast. So it's x minus 4 because we're going to the right, 4 squared, plus y minus 2 because we're going up, squared is equal to 3 squared because your radius was 3. But the cleaned up version of this, I should say, is y minus 2 squared is equal to 9. So this is technically what I want you to give me as a final answer. All right, and 110. In second period, we actually didn't get to finish this all the way. So 110, you can actually go around and figure out A through F. I'm just going to work on the circle itself. So I'm just going to work on labeling every single part that I actually know we can actually do. So the first thing is inscribed angles. There's actually 4 of them on here, so we're going to use the 4 to our advantage. This part here belongs to this part of the circle. That's an inscribed angle. So your intercepted arc out here is going to be double 63. So if it's double 63, it's going to be 126 degrees out here. And then this part of the circle, right, actually subtends the same arc. So this angle here, I'm going to go slow so you can see which one I'm talking about, subtends the same arc. So this is going to be 63 also because, well, they're both part of the same arc. All right. Now, it does say that QS is your diameter. So that means from Q all the way to S, so this half of your circle is going to be 180 degrees, which leaves the other half of your circle 180 degrees also, which gives you a wonderful answer for Q to O, because if this part is 80, the whole thing is 180 from Q to S. This is going to be 100 degrees because 100 plus 80 is 180. And then this arc out here, which is 100 degrees, is actually subtended by this angle in here. So that's 50 because that's half of it. And then this angle here, which subtends this one also, gives this one in here 50 degrees. Okay, now the difficult part about this, the rest of it, is to try to remember what you really have as your background is a triangle. So this triangle here, the one I'm shading right now, is, well, basically just a triangle. And you have 50 degrees here, you have 63 degrees here, adds up to 180, right? So figure out what this angle is, and then you're going to pretty much do the same thing with this little triangle on the other side. It's not a big surprise here. This is 63 degrees, this is 50 degrees, and then what's this angle here? So that should pretty much give you the rest of these. I don't think it's asking for anything crazy, so you should be okay. Yep, you should be fine. Alright, that was 110. 111. Kind of the same thing, but a little bit more involved, I guess. So in the diameter, AB is, I'm sorry, in the diagram, AB is the diameter. Okay, so that pretty much tells me that this whole thing here is 180, and then from here to here, it's 180. All right, that takes care of that. So if BC is 5 and AC is 12, use the relationship shown in the diagram to solve for the quantities listed below. Okay, so let's see what we know. We know BC is, well, first of all, this is 180, and this angle here is going to end up being 90 because it's half of 180, which is the distance, or the degrees from A to B. So A, D, B, so that was going to be 90 degrees. BC is 5. Okay, so from B to C is 5. Not degrees, just lengthwise. It's from B to C is 5. And AC is 12. So this is 12. Okay, well that should help you actually a lot. 12 and 5. Okay, so we have a right triangle, if I'm not mistaken. That's 5, this is 12. If you do Pythagorean theorem, you should get that this is 13. So that means A to B, this whole distance here, which is that one, is really 13. Okay, so that should help you because half of 13 is going to give you 6.5. So your radius is really 6.5. So A to B as a length, because that's what this is, the first one, it says A to B as a length is technically 13. That's what you found. The length of the radius is going to be equal to 6.5 because there's not, you just half of 13. The measure of angle ABC, A to B to C, okay, that one we definitely need to do, and then the arc AC. All right, so what you're really asking for in this case is to find, I guess you can say find X over here, because that's your angle ABC. That's X. So it's really up to you what you want to do. If you want to use sine, if you want to use cosine, if you want to use tangent, that's pretty much up to you. You should get, actually I don't know what you should get, but I do know you need to use the trig function, so hopefully you did it correctly. Okay, yeah, and then eventually you're going to have to use inverse. So you're going to have to use inverse tangent of whatever, of X. You're going to have to use inverse sine, or you do inverse cosine. You have all three sides at your disposal, so it doesn't matter which one you do. You can actually try all three of them if you want. You should all get the same answer for all of them. The angle isn't going to change. And then whatever you find for X, since AC, which is this one right here, this is part D, subtends this arc down here. I'm sorry, angle X, I should say, subtends this arc out here. If you, whatever you find, you double it, you should be able to get the measure of AC. All right, 112 is solve each quadratic equation below using any method that you choose. Please remember, I'm just going to say for all of them, just go for all of them. You have to get it equal to 0, like A and C. So if you're going to, when you start B, when you start D, if you don't like the Y's, you could change them to X's. I don't really care. They're all the same thing. Please make sure that you're solving each of these using any method. So you can factor if it's possible. So factoring, you do like the box, and you put the x squared term here, the last one here, and then you do the diamond, or you complete the square. So that means everything has to be the same. You're going to have to add on both sides or subtract on both sides. Or you can do quadratic formula, and that has its own things. Just remember the formula for that matter. So you have three choices: complete the square, factoring, or quadratic formula. All right, and this will definitely be on your test. On your quiz, and then on your test too, solved by any method. All right, number 113. Write an equation and use it to solve the problem. A 1 foot tall cylinder, or Jill has a 1 foot tall cylinder that she is using to catch water leaking from a pipe. The water level in the cylinder is currently 2 inches deep and is increasing at a rate of 1/4 of an inch per hour. How long it will be before that water overflows? Okay, so you're talking about a cylinder in general. Okay, so what is this going to look like? Oh yeah, so right, pretty much like this. Here's my cylinder. So if you really want to say, it'll look like this, and then it'll be like that. It's like a roll of paper towels, which it really is a roll of paper towels, except it's got the base and the top to it. So 1 foot tall cylinder basically means it's 12 inches. It's 12 inches tall. That's a foot. She's using to catch water. The water level is currently 2 inches deep, right? So she's at 2 inches. She's got some water in here. It's blue, sparkling water, 2 inches. And it's currently going at 1/4 of an inch per hour. So you can actually create a table from this if you really want to. Here is your time, right? And here's how much water you have. So currently, we're just going to say currently, 2 inches deep. So let's say at time 0, the water is 2 inches. And then in an hour, it's going at 1/4 of an inch per hour. So it would be 2.25 inches. And then in 2 hours, it's another 1/4 of an inch. So it would be 2.5 or 2.50 inches. 3 hours later, it's going to be at 2.75 inches, right? 4 hours, it's going to be at 3 inches. Oh boy. Okay, well, create an equation. Okay, thank you, because this would take me forever. So you're actually going up every single time by 0.25. So your slope is 0.25, right? 0.25, 0.25, because you're adding 25. 1/4 of an inch per hour. And let's say you started at 2 inches. So let's say that's our starting value. So your equation is going to be y equals, what do we have? 0.25x, right? And then plus 2. Okay, so the question is, well, the answer is 40 hours, but why? The question is, how long is it going to be before the water overflows? So you want to figure out, when is it going to be 12 inches? So 12 for the y, 0.25x plus 2, and then solve for x, and you should get 40, or in this case, 40 hours, right? That's our units. Okay, that's your equation. Or this would be a better equation, and then that was the second part of the question. That was 113. What am I at, 13 minutes? Okay, 14. Oh boy, this is a little crazy. We have, what is the area of a regular decagon with a perimeter of 100 units? Okay, so this should be pretty easy to do. I'm going to set you up for this. You need to find the rest of it. The perimeter is 100 units, so that basically means each side is going to be 10, because it's a 10-sided figure. So 10, 10, 10, 10, 10, 10 all the way around. 10 and 10 and 10. The area, by the way, is find the area of one triangle and multiply by how many sides you have, in this case 10. So 10 sides minus 2 times 180, 8 times 180, and that is a really interesting number. 8 times 180 is 1440 divided by 10. 1440 divided by 10 is 144. 144 divided by 2 is going to give you 72. So these interior angles here are 72 degrees, 72 degrees. These angles here, right? Before I cut them in half, were all 144s of each other. 144, 144, 144, all the way around. So now you have a triangle, okay? I'm going to blow it up a little bit bigger. This base is 10, 72 degrees. You don't know what the radius is, so please do not assume it's also 10. It's obviously not 10. It doesn't even look like the picture. But you do know if you drop an altitude, or in this case the height of this triangle, this is going to cut in 5 and 5. So now you need to use trig and find the height. So I'm going to say, okay, well, let's say the height is x. So you have a right triangle, right? 72 degrees, you have x, you have 5. Find the value of x. And then the area of your triangle is going to equal base times the height divided by 2. So your base is 10. Your height is whatever you find for the value of x after you use tangent to actually find it. And then divided by 2, whatever you get for the area of the triangle, right, is your answer. And then multiply that by 10 to get the area of the whole thing. All right, and then that was 114 and 115. Yes, I'm on time. PQR at the right, what is the measure of angle Q? Oh boy, this is not going to be fun. Really? Explain how you found your answer. Oh boy, what is this? PQR at the right was... I don't even know how to do this. Alright, this might take some thought process. I need a couple of silent questions so I can think. A silent. Okay, I think I'm going to have to come do this really quickly in another video. So, I'm going to stop because I actually have to think about this problem for a second or two and then put this one on the next video.